Nowadays, token-based authentication has become more and more popular in the development of web and mobile applications. There are many different types of token, but among them, JSON Web Token or JWT is one of the most widely used. However, in the past few years, we've also discovered several security issues regarding JSON Web Token, mainly because of its poorly designed standard. So recently, people have started migrating to other types of tokens such as PASETO, which promises to bring better security to the application. In this lecture, we will learn everything about the security issues of JWT and how PASETO is designed to solve all those problems. First, let's talk a bit about token-based authentication. Basically, in this authentication mechanism, the client will make the first request to login user, where it provides a username and password to the server. The server will check if the username and password are correct or not. If they are, the server will create and sign a token with its secret or private key, then sends back a 200 OK response to the client, together with a signed access token. The reason it's called access token is that later the client will use this token to get access to other resources on the server. For example, let's say the client wants to get a list of bank accounts which belong to the login user. Then it will make a get account request to the server, where it embeds user's access token in the header of the request. Upon receiving this request, the server will verify if the provided token is valid or not. If it is valid, the request will be authorized, and a 200 OK response will be sent back to the client with a list of users' bank accounts. Note that an access token normally has a lifetime duration before it gets expired, and during this time, the client can use the same token to send multiple requests to the server. So that's how the token-based authentication works. Now let's talk about JSON Web Token. Here's an example of a JSON Web Token. It is a base64 encoded string composed of three main parts, separated by a dot. The first part with color red is a header of the token. When we decode this part, we will get a JSON object that contains a token type, JWT, and the algorithm used to sign the token, HS256 in this case. The second part in purple of the token is a payload data. This part is where we store information about the login user, such as username, and also the timestamp at which this token will be expired. You can customize this JSON payload to store any other information you want. In this case, we also have an ID field to uniquely identify the token. It will be useful in case we want to revoke access of the token in case it is leaked. Keep in mind that all data stored in the JWT is only base64 encoded, not encrypted. So you don't need the secret or private key of the server in order to decode its content. It also means that we can easily encode the header and payload data without the key. So how can the server verify the authenticity of the access token? Well, that's the purpose of the third part of the token, the digital signature in blue color. If you don't know how digital signature algorithm works, I recommend you to watch my video about SSL and TLS before continue. The idea is simple. Only the server has a secret or private key to sign the token. So if a hacker attempts to create a fake token without the correct key, it will be easily detected by the server in the verification process. The JWT standards provide many different types of digital signature algorithms, but they can be classified into two main categories. The first one is symmetric key algorithm, where the same secret key is used to both sign and verify the tokens. And since there's only one key, it should be kept secret. So this algorithm is suitable for local use only, or in other words, for internal services where the secret key can be shared. Some specific algorithms which belong to this symmetric key category are HS256, HS384, and HS512. Here, HS256 is a combination of HMARC and SHA-256. HMARC stands for Hash-Based Message Authentication Code, and SHA is a secure hashing algorithm. 256, 384, or 512 is the number of output bits. Symmetric key algorithm is very efficient and suitable for most of the applications. However, we cannot use it in case there's an external service that wants to verify the token, because it would mean we must give them our secret key. In that case, we must use the second category, asymmetric key algorithm. In this type of algorithm, there's a pair of keys instead of just one single secret key. The private key is used to sign the token, while the public key is used only to verify it. Therefore, we can easily share our public key with any external third-party services without worrying about leaking our private key. Within this asymmetric key category, there are several groups of algorithms, such as RS group, PS group, or ES group. Here, RS-256 is basically RSA algorithm with PKCS version 1.5 and SHA-256. PS-256 is also RSA algorithm, but with probabilistic signature scheme and SHA-256. It was designed to be more secure than PKCS 1.5. And the last one, ES-256, is simply elliptic curve digital signature algorithm with SHA-256. Okay, so far it sounds like JWT is a good standard, and it gives us a lot of flexibility to choose whatever signing algorithms we want. So what exactly are its problems? Well, the first problem is weak signing algorithms. JWT gives developers too many algorithms to choose, including the algorithms that are already known to be vulnerable. Such as RSA with PKCS version 1.5 is susceptible to padding oracle attack, or elliptic curve digital signature algorithm can face invalid curve attack. For developers without deep experience in security, it would be hard for them to know which algorithm is the best to use. So the fact that JWT gives developers too much flexibility to choose the algorithm is like giving them a gun to shoot themselves in the foot. But it's not the worst. JSON Web Token makes token forgery so trivial that if you are not careful in your implementation, or if you choose a poorly implemented library for your project, your system will easily become a vulnerable target. One bad thing about JWT is that it includes the signing algorithm in the token header. Because of this, we have seen in the past, an attacker can just set the algorithm header to none to bypass the signature verification process. Of course, this issue has been identified and fixed in many libraries, but it's something you should carefully check when choosing the community-developed library for your project. Another more dangerous potential attack is to purposely set the algorithm header to a symmetric one, such as HS-256, while knowing that the server actually uses asymmetric algorithm, such as RSA, to sign and verify the token. Let me explain how. Basically, the server's RSA public key is clearly known to the public because it's a public key. So the hacker can just create a fake token of the admin user where he purposely set the algorithm header to HS-256, which is a symmetric algorithm. Then he just signs this token with the server's public key and use it to access the resources on the server. Now keep in mind that the server normally uses a RSA algorithm such as RS-256 to sign and verify the token. So it will use a RSA public key as a key to verify the token signature. However, since the token's algorithm header is saying HS-256, the server will verify the signature with this symmetric algorithm HS-256 instead of RSA. And because the same key is used by the hacker to sign the token payload, this signature verification process will be successful, and the request of the hacker will be authorized. This kind of attack is very simple, but still so powerful and dangerous. And it has actually happened in the past because the developer didn't check the algorithm header before verifying the token signature. So in order to prevent this attack, it's crucial that in your server code, you must check the token's algorithm header to make sure that it matches with the one your server uses to sign and verify tokens. Okay, so now you know why JSON Web Token is not a very well-designed standard. It opens the door to many potential threats. Therefore, many people are trying to stay away from it and migrate to something more robust. PASETO, or Platform-Agnostic Security Token, is one of the most successful designs that are being widely accepted by the community as the best secure alternative to JWT. It solves all issues of JSON Web Token by first providing strong signing algorithms out of the box, so developers don't have to choose the algorithm anymore. Instead, they only need to select the version of PASETO they want to use. Each PASETO version has already been implemented with one strong cipher suite, and at any time, there will be at most 2 latest versions of PASETO are active. Right now, 2 active PASETO versions are version 1 and version 2. Version 1 is older and should only be used for legacy systems that cannot use modern cryptography. Similar to JWT, PASETO also has two algorithm categories for two main use cases. For local or internal services, we use symmetric key algorithm. But unlike JWT, which only do base64 encode the payload and sign the token, PASETO actually encrypts and authenticates all data in the token with a secret key, using a strong authenticated encryption with associated data algorithm or AEAD. Again, if you don't know what AEAD is, you can watch my video about SSL TLS. The AEAD algorithm used in PASETO version 1 is AES-256-CTR with HMark SHA-384. For public cases where there are external service that needs to verify the token, we have to use asymmetric key algorithm. In that case, PASETO uses the same approach as JWT, which means it doesn't encrypt the token data, but only base64 encode it, and use a private key to sign the content with a digital signature. The chosen asymmetric key algorithm in PASETO version 1 is RSA-PSS with SHA-384. In the latest version of PASETO version 2, two more secured and modern algorithms are being used. For local symmetric key scenario, it uses SHA-20 with Poly 1305 algorithm. And for public asymmetric key scenario, Edward Curve digital signature algorithm with curve 25519 is used. This choice reminds me of how the TLS 1.3 was designed to improve the security of its older version TLS 1.2, and also simplify and reduce the number of TLS cyphersuits at the same time. Now with the design of PASETO, token forgery is no longer trivial, because the algorithm header doesn't exist anymore, so the attacker cannot set it to none or force the server to use the algorithm it chose in this header. Everything in the token is also authenticated with AEAD, so it's not possible to tamper with. Moreover, if you use local symmetric key algorithm, the payload is now encrypted, not just encoded. So it's not possible for hackers to read or change the data stored in the token without knowing the server's secret key. Sounds amazing, right? In the next lecture, I'm going to show you how to implement both JWT and PASETO using Golang. You can see PASETO not only makes it safer, but also easier and so much simpler to implement compared to JWT. For now, let's take a look at the structure of a PASETO token. This is a PASETO version 2 token for local usage purpose. There are four main parts of the token separated by a dot. The first part is PASETO version with red color, which is version 2. The second part is the purpose of the token. Is it used for local or public scenario? In this case, it is local, which means using symmetric key authenticated encryption algorithm. The third part with green color is the main content or the payload data of the token. Note that it is encrypted, so if we decrypt it using the secret key, we will get three smaller parts. First, the payload body. In this case, we just store a simple message and the expiration time of the token. Second, the nonce value that is used in both encryption and message authentication process. And finally, the message authentication tag to authenticate the encrypted message and its associated unencrypted data. In this case, the unencrypted data is the version, the purpose, and the footer of the token with purple color. You can store any public information in the footer because it won't be encrypted like the payload body, but only base64 encoded. So anyone who has a token can decode it to read the footer data. In this case, it is Paragon Initiative Enterprises, the one who invented PASETO. Note that the footer is optional, so you can have a PASETO token without footer. For example, this is another PASETO token for public usage scenario. It only has three parts with no footer. The first part is PASETO version, which is version 2. The second part is purpose, public in this case, which means an asymmetric key digital signature algorithm is used to sign the token, and its payload data won't be encrypted, but only base64 encoded. As you can see here, the green part of the payload is actually the encoded body, which we can easily decode to get this JSON object, while the blue part of the payload is the signature of the token, created by the digital signature algorithm using the private key. The server will use its paired public key to verify the authenticity of this signature. And that's it for today's lecture about token-based authentication. We have learned about the design flaws of JSON Web Token that causes many security issues in the past, and how PASETO were invented to fix all those problems, and thus make our developers' life much easier. I hope you like this video, and see you in the next one, where we will write code to create and verify JWT and PASETO token in Golang.